So welcome to the final video report of the fifth challenge of our hackathon. The fifth challenge is called SmartAfriHub 3, African Agricultural Water Security. There were a lot of participants, it was 18. Among them were 8 guys from Africa. One of them will speak today. His name is Ronald. And then also another speaker will be Karel, whose contribution is very welcome. So Ronald, the floor is yours.
Thank you, Marketa. I don't know what to say. Is it good morning or good afternoon to everyone? But my name is Semba Ronald, as Marketa has indicated. I was part of this hackathon, and I'm from Uganda. I work as a agrometeorologist with the National Agriculture Research Organization. I guess that's enough about me. So let's head straight into this. Taking you through the background, this hackathon, this challenge specifically builds from a couple of different Inspire hackathons that have been running through, from the Nairobi Inspire Hackathon to the COVID Inspire Hackathon and the Kampala Inspire Hackathon. So we have a couple of results from different hackathons that we've combined together in what we've called the Digital Innovation Hub, or which you can call SmartAfriHub, and a couple of other social media links. So we have also been working together with 3 different challenges in this hackathon, and that is Challenge 1, Challenge 2, and Challenge 3, which is about analysis of Sentinel-1 and Sentinel-2 time series for application in agriculture. So next slide, please. So now we go to, this is our composition. We have members like Marketa has indicated in the introduction, from different countries all over the globe, as displayed in this map here. We have a 3-pillar approach that includes the datathon, whereby members gather together to collect relevant data. And in this case, we've cited different data sets that would help in analysis and identification of analysis of the identified problem, which is potential farming, potential irrigation systems. So another component of, excuse me, I had to get off this screen display here because I couldn't see well the screen. Our other approach is Ideathon, whereby we gather together and process different ideas and plans on how to go ahead and provide different solutions. Another component or approach is the Educathon, whereby we combine different learning tools and sessions and train different individuals or members in this group, in this challenge, on use of different tools such as geospatial analysis tools and different communication tools in different platforms. Next slide, please.
Okay, as Ronnie mentioned, we develop also a number of data during the datathon, and for your information, this time we focused too much on the development of the platform, but on the publishing of the data of the platform. And all data sets which was developed, you can see if you will open opening page of SmartAfriHub, only clicking on some of this image, and you will be directly moved to the map. So Ronnie, you can continue.
Okay, thank you, Karel, for that. Well, one of the first things we had to do is to assess the current status and needs so as to answer the different challenge we have, questions, the different challenges we had at hand. And one of the things we've actually gotten to discover is that from a combination of ideation sessions and the available literature, we've learned that the biggest portion of agriculture of water in Africa is claimed by agriculture. However, only 6% of the total land in this region which is actually roughly 185 million hectares, is under agricultural use, in this case, cultivation. And actually, worst of this is that about 6% of this is under irrigation. And this sort of like highlights the food insecurity problem in Africa, because it turns out that the sector is largely rain-fed, reliant on rain-fed agriculture. So solutions are sought to curb this problem, because the rapidly growing population in this region of Africa is posing many issues as regards food security, of which various effects are associated with this that include the insecurity and that include the malnutrition and conflicts in different areas. So our solution here is that we thought for solutions and realized that there's need to optimize both land use and irrigation potential, so as to increase agricultural production and productivity. Next slide, please. Well, and right here, we realize that there's not going to be a one-fit-all solution that can really span the different human and natural dimensions. So we thought to put together a combination of approaches and tools to optimize the available open source observation resources and data and tools, so as to inform government and local farmers on policies and just-in-time farm or local level decision-making and intervention. So these include mapping of land use activities, which include a number of methods and classification tools that Karel will discuss later. It also included monitoring of vegetation conditions, because this helps in informing real-time intervention. What needs to be done, when and at what time, how much water needs to be added when and at what time. And we also intended to monitor water resources, their conditions, their quality, their amount of available water resources, because a combination of these will inform the right decision that is needed by the local farmer or governments in Africa. Karen.
Okay, as already Runar mentioned, we work a lot with the data, and to analyze the situation in Africa, we try as first to collect available Pan-African data and making this easy accessible, and together with challenge 2, attractiveness of region, we also compare situation in different countries of Africa. On SmartAfriHub, you can see the result, and the challenge 2 will much more deeply presented how this comparison of countries was done. For this water irrigation crop monitoring, we work at first stage mainly on the development of open land use for Africa. The main problem is that the data which now exists for Africa are in very small scale and with lack of detail and lack of information, and we thought how we will be able to improve this data. You can see two data sets which cover all Africa and which could be used, but you can see the level of the detail. Already in past hackathons, we work on open land use for Africa to combining this data with local data and to try to improve the data, but all it was not enough, and together with challenge 1, which define the multi-layer model for open land use, which is done now in Europe, we try to use this model in Africa, and we think how we can make much more detailed maps and how we can combine this with other data. And because this multi-layer model, there is some basic geometry, and then you are able to put into this data different thematic view. So we decided to take existing data of land use and combine this with probably the best data set which exists for Africa, and it is OpenStreetMap. And on the base of the combination of this data, we built the basic geometry for countries in Eastern Africa, covering Kenya, Tanzania, Uganda, Burundi, Rwanda, and we cover all these 5 countries with these maps. And we started also build thematic view on this map, combining different inputs and building different type of thematic maps for these countries. What is important that this multi-layer model is able also integrated results from Earth observation data. You are able to combine this with indexes or with classified data, calculate the statistics, and make then some assessment of this every area, and to make much more precise classification. Here you can see some statistics which was done for single areas based on non-supervised classification. So we calculate for every area which classes of unsupervised classification are inside of every polygon, and then we provide classification of this polygon. This is way how we are able to combine existing vector data with Earth observation data. It is in some way based on ideas of GeoBia methodology, and we see this as a big future for monitoring of Africa and to building maps which will be able to help by for countries, but also for regional organization. As I mentioned, we work a lot of with different type of indexes. Also, Ronald mentioned that it was important for providing some assessment. We compare different indexes, including Sentinel-1, but also Sentinel-2. As probably you know, Sentinel-2 is able to work also through the cloud. So you can see that on some data up from Sentinel-1, you can see here clouds, but if you are Sentinel-2, but if you are working with Sentinel-1, there are no clouds, and you have this data for all periods. So in the combination of different type of the data, we are able to receive better classification and better interpretation of the things. On the hub, you can find the series from all season of all 3 types of the indexes. So you can also follow on the hub the development of vegetation in this region. Due to the limited time and resources, we done this only with one scene from Sentinel-1 and Sentinel-2, but now there is already methodology which could be extended and done in larger scale. Other topic, as Ronald mentioned, was the monitor the quality of the water. When we start to visualize data from water, we were very surprised because we saw on the images strips, And we thought, where is our mistake? What we are doing wrong, that there are such strips on the water. But then we start to study literature and look on this, and we recognize that it is something what is common for this data from Sentinel-2, and so that we need to in the future deal with the problem that there are these different strips. We then look on a different combination of spectral bands and indexes, and on the and we select the spectral band 5, and we prepare some visualization. You can see that there is on this spectral band is possible in the water to see the different effect, and of course this effect has to be later studied. Again, the time was not so long to compare this with some samples, but this is the base for future activity. This was from this data work, and I think that, Ronald, you have now to conclude our presentation.
From the above. Okay, now from the above presentation and results, we present our conclusions as below. Our community is one that is always expanding, and we're having to develop a number of content that is being published at the hub that can be used all over Africa in different ways. Also, the new ideas and analysis of needs in African farming sector have been collected, analyzed, and visualized. So we think all this content can really be applied differently. And the good thing about it is that this kind of data and analysis are presented in very high resolutions that can spark high level and low level decision making. Our next steps is developing more tools to analyze and assess the quality and validity of the generated results, and also working together with different geospatial stakeholders like the geo community, the Copernicus, and all these different players in geospatial data and analysis to promote these results in different African states and different groups. So my concluding remarks would be that this is quite a huge potential that can be harnessed in all these different results and open data that has been availed at the different African farming sector players to utilize in order to improve productivity and production of agriculture at the continent and contribute to the different SDGs. Thank you.
Okay, so thank you all for your attention. Here you can see the contribution.
Yeah, so these are our details.
Yes, so I would like to say a special thank you to Tula, who maybe left already. But Tula, thank you. You're the heart of our challenge. It was a great job done by you and by all guys. Thank you very much. It was a great time we spent together. So I hope our cooperation will continue. Really, thank you.
Thank you, Marketa.